Good day, internet. Now it is getting to day 5 of the Advent of Code Christmas calendar. So far, I've been able to get through through the previous puzzles on the C64, which is pretty good, which is pretty cool. But let's see how far we can take this. Cool. Okay. C64 is booted. Floppy disk drive is on. Cool. Let's get going. Yesterday I did a new feature into the editor. I added this integration between my C++64 editor and the Advent of Code client program. So instead of loading up the Advent of Code client program, what I do is I load up the editor directly, and if I tap on Commodore A, the screen goes all funny, but what it does, it directly loads the Advent of Code program from the editor. So I don't have to restart the C64, then load it up, then reboot again, and then restart the editor. So that makes it quite a bit easier to switch between the two. Cool. All right. So I need some coffee. Let me grab some of that. Okay, coffee is loaded. And day 5. Here we go. If you give a seed a fertilizer. Okay. Do you need specific hardware to run your setup on C64? Hi, Speckiest. Yes and no. So yeah, to make this full setup complete, I do need special hardware. So I have this this Turbo Chameleon 2 cartridge, and I use it for a RAM expansion unit. So with a RAM expansion unit, I can hot swap between the the editor and the code that I program. And then there's this RRNet cartridge that has an Ethernet port. So I get to do the cross development. So I write the code here, and then it sends the code to the PC that compiles, and then it sends it back. So that's used with the network cartridge. But when I'm actually running the puzzle program, I'm running it in on the disk drive, or the puzzle input is on the disk drive. So there's I don't need the network card for that. And currently I don't use the RAM expansion unit, but I think that's kind of like a secret weapon that I'm holding reserve. Like when these problems get too hard, I have the RAM expansion unit there that I'll be able to latch on to get a little bit more memory than C64. Hey there, hi Armand Lex, how's it going? Deadly curious to see how you're gonna tackle this day. Oh no, is that some kind of ominous foreshadowing or something? Let's see what's gonna happen. Okay, so you take the boat and find the gardener right where you told he would be. You managing a giant garden that looks more to you like a farm. Okay. A water source? Island is the water source. You point out that the snow island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with the dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? Okay. You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The Almanac, your puzzle input, lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed. What type of fertilizer do you use with each kind of soil? Oh dear, okay. What type of water to use with each kind of fertilizer? So we have seed, soil, fertilizer, water, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number. But numbers are reused by each category. That is soil. Numbers are reused by each category. That is soil 123 and fertilizer 23 aren't necessarily related to each other. Okay, so they have each their own namespace. For example, seeds. Seed to soil map. Soil to fertilizer map. Well, this is like one line, like 1 by 4. This is 2 by 3. This is 3 by 3. Fertilizer to water map is 4 by 3. Water to... Oh, there's water to light. Light to temperature. Temperature to... Oh my god, what is this? Temperature to humidity. Humidity to location. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. So that's all the numbers. 79, 40, 50, yeah. Okay. So these seeds need to be planted. The rest of the almanac contains a list of maps which describe how to convert numbers from source category into destination category. That is, section starts with the seeds to soil map that describes how to convert the seed number source to a soil number destination. This lets the gardener and his team know which soil to use and which seeds, which water to use with which fertilizer and so on. Seed to soil. So this is a seed to soil. So 50 goes to 52, 98 goes to 50, 82 goes to... But those don't match directly with these numbers. Rather than list every source number and corresponding destination one by one. Ooh, the maps describe entire ranges of numbers that can be converted. Each line within a map contains 3 numbers. The destination range starts the source range start and the range length. Oh, I see. Destination range start, source range start, range length. Okay. $50. Source range start 98, range length of 2. This means that the source range starts at 98 and contains two values, 98 and 99. Destination range is the same length, but it starts at 50. Seed number corresponds to soil number 50. Seed number 99 is 51. The second line means that the source range starts at 50. Okay, so these are two independent mappings. This corresponds to a destination range starting at 52 and containing 48 values. Got it. Any source numbers that aren't mapped corresponds to the same destination number. So seed number 10 corresponds to soil number. Okay, so if we had a number here that wasn't, yeah. So the entire list of seed numbers and the corresponding soil numbers looks like this. Seed, soil. Got it, okay. So we map these with the functions. Want to get started as soon as possible, so they like to know the closest location that needs a seed. The lowest location number that corresponds. Ooh. The closest location that needs a seed. Using these maps, they find the lowest location number that corresponds to any of the initial seeds. Lowest location number is 35. What is the lowest location number that corresponds to any of the initial seed numbers? So location was the last. Wait. Yeah, humidity to locate. Okay, location is the last one. So we want to map through with these functions and then find the smallest. Fair enough. Okay. I need a pen and paper because I'm gonna lose this description. Here's my paper. Where is my pen? My pen. Okay, now I lost it. I'll find a pen. Just give me a second. Oh, here it is. Okay. So we go from seed up Then we have soil. Then fertilizer. Then water. Then light. Then temperature. Then humidity. And finally location. Yeah, it's a big ass description. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So 7 maps. And we want to find... So the first line is the inputs, I guess. The seeds. Seeds. And then we get numbers. And then I have soil to fertilizer map. And then the numbers go here. Okay, and then lowest location number in this map is 35. So that's what I'm looking for. What is the lowest location number? Okay, so let's save the inputs. So I need to save this one. So we start here. And here, and then save 20, oh, save to device 8, 2023.example5.txt. Cool, that's there. And then shift, oh, actually, where's the input? Okay, your puzzle input, shift I, save to device 8, 2023.input5.txt. Okay. Oh no. My C64 drive light is blinking. So that means that actually I think I have run out of disk space. Yeah, I think that's what happened. Okay. Do I have any space on my floppy? Let's see what happens. Yeah, 0 blocks free, so I'm run out of memory or disk space. Okay, so I'm gonna delete this one. I think, does this work like this, or do I have to clear this? Maybe that works. Oh no, it didn't work. Scratch 2023.input5.txt. I don't want to leave these things behind. Yeah, okay. Wait, saying absolutely 0 blocks free. That's weird because Did I lose some blocks? Like, are there like orphan blocks? Because I yeah, there must be some type of like orphan block thing or something going, because it can't be the case that these things just magically just happen to fit on this drive. Wow, okay. I need to figure that out, but I don't have any other solution here except yeah, I am going to break out another disk. So I have another Kodak, new old stock. I don't know where these came from, but I have another Kodak diskette that I can use. So I'm just gonna use this one. Oh, actually, no, these are pre-notched. Wait. Oh, but this one isn't. That's weird. Oh, I have probably notched this myself with like just a pair of scissors when testing or something like that. Yeah, so okay, so what I'm gonna do actually, let's see if this disk reads. What do I have on this disk? Oh. Drive not ready. Oh, I need to close that lid, of course. No, what? Drive not ready. Did I botch something up? Or maybe that is not formatted. Another demo. Ooh, I've downloaded some demo on this disk. Okay, so I need to format this disk. But I don't remember what the command is, so I need to figure out what is the command to format the disk. $N colon name AOC ID 01. Wait, no, it just... Oh, I did $. No. It needs to be at symbol. At new colon name and ID. What does the notch do? So the Commodore disk drives have only the read-write head on one side of the device. So this magnetic media, of course, exists on both sides, but there's no physical like read-write head only on one side of the disk. So if you manually flip the disk, then you can save on the other side. But the issue is that there's a read-write protect. So you can only write to a disk if there's a notch here. So of course, when you flip it, you don't have this notch, so you have to manually make this notch to write to the disk. So that's why you end up having these dual notched things on the C64. And that's something like that never happened on the PC. I don't think they ever had like one-sided discs. Okay, so now I have AOC. So I have a disk here that can contain my input. Let's put this here, and now let me grab C++64. That's great. I mean, yeah, Commodore say like, you know, like it's like a competition between ZX and Commodore. Like, who saved more on more stuff? Like they skimped on so many things. Okay, so save instructions over there. Here. I bet the manufacturer didn't like the idea of using both sides. I think they probably were designed for that. Like because they were like these professional notch cutters and all of this this stuff. So I think, I mean, I never had a disk drive back in the day, so I don't quite recall. I only had a tape drive back then. Okay, so here, save 8 2023 dot example 5.txt. Okay, so now I got the example and then the input. Shift I, save to device 8. 2023.input5.txt. Okay, so now hopefully this thing shouldn't start blinking on me. And yeah, I need to figure out, because I think I've lost some blocks on this disk. Like they must have been orphaned, like when there's like a disk error or something, because I don't think the block numbers added up to like, I think like 500 or 600 or whatever they're supposed to be. Okay, now there's no blink, everything is good. So now I've got the input over there. And now, so what should happen if I press restore? Yeah, so I get back to the editor by pressing restore. So I don't need to reboot or anything. I can switch between AOC program and the editor at will. That's pretty cool. Okay, so now we can get going with this crazy thing. Oh, and this squiggle error, I see that is persisting. Cool. So do the usual mantra. And first we skip the seeds part. Then while read the seeds in. Oh, actually, I wanted to, now I forgot. 2023.5a.cp. Okay, so actually now I want to look into, so Commodore A. Yeah, so I want to see if I can take a peek of the input here. If this can fit in memory. Oh yeah, it does, okay. What? These numbers are crazy. Okay, so I guess I am not doing like... Well, thanks for this. Jeez. Why couldn't they be like nice small numbers? Are they bigger than uint32? So that's a million, that's a billion. So billion is 3, 6, 9, 10 numbers. So that's 10 numbers. There is also 10 numbers. I think these all fit in a U32. They fit in long though. Well, I mean, depending on which platform you're on, like your long might be different. Like, but yeah, U64 they definitely will fit, but. I'm gonna go with the assumption that they will fit in a U32, in a 32-bit integer. Okay. So I need to do a binary tree. I'm using 8 bytes signed on everything, and I got part 1 right, so it probably works. Yeah, I mean, 8 bytes will definitely work. 8 bytes will definitely work, and I think 4 bytes will work as well. So I'm gonna go with that. And this seeds, okay, though, so that's gonna be. Okay, cool. So seeds. So U32. Cool, alright. Okay, so that works. So I've got the seeds. Okay, and then... so I need to do a binary map for... to fit these ranges. So that would be like... that I could be walking like left, right, left, right. Let's try that. Struct. Or do I just do a flat? Well... No, I'm gonna do... well, actually... how many of those rules are there? Actually, let's take another look. So if there are just a few rules per stage, then I'm not gonna bother with any of this binary map stuff. Otherwise, I'm just gonna do a linear read. Oh, there were a lot of those, so that's one screen full. Okay, yeah, I'm gonna die if I don't do a binary. Okay. So, node. Low, high. Node. So I'm gonna have like a binary node that is the start of the range and then the end of the range, and then the like the destination or yeah, the map the mapping, and then I'm gonna do left and right children. Field has incomplete type, no. Oh, no. Okay, so now I get a binary tree. So let's see, I have node star alloc, node n equals node star c alloc 1 size of node. Return. So I have now one node for a binary map. And fscanf soil to fertilizer map. So I'm gonna skip that one. Right. Skip that one. And then, oh, by the way, actually, I had yesterday's program, I had a bug. So I had this fscanf like this. To be proper, I need to have this greater than 0 here to be standards compliant. Because in my C runtime, I return 0 when this fails. But on other systems, this might return EOF, which is a -1. So I noticed that when I was running this thing later on a PC. So while actually now I need the helper function node read node. Read node star fertilizers equal read node. And now I get, how did it go? Destination, source, length. File, fscanf. Goes to destination, to source, and then the length. So I get the root. Okay. Read nodes from file. And I get node star n equals alloc n oh, I'm gonna need a random number generator, am I? Maybe I am. We'll see. N flow equals source. N high equals source plus length. I need to remember this is a half open interval, so that's like low, high, and then n destination equals PSP. Okay, and then if I don't have a root yet, n equals root. Else yeah, else insert n root. Okay, this is turning out to be a little bit bigger program, and now I actually have is this question of, so I have 4,478 bytes free in my editor, and I'm slightly worried whether I'm gonna run out of memory in my editor for that to work. But we'll see. Node void insert node n node parent. And if node, so now I need to figure out, so does node go on the left or right child of P? So if node high is smaller than equal parents, I'm assuming that these are disjoint. Then this goes to the left. It's gonna be a magic loop. Yeah. If not key left equals n to parent. Otherwise P equals P left. Else if node well, I mean this is implied, this should now hold if these are disjoint, is greater or equal parents I. If not parent right equals node parent. P equals parent right. Else not this point. Well, there's some extra characters there. Yeah, I think I like this. This looks good. This looks good. So let me save. And then I have U32 map, U32 seed, node root. And now we get to do the function map. While root. If seed is greater than equal root low and seed is smaller than root high, return seed seed minus root low plus root DST. That's not greatly named. Yeah, that's where is it now? Here. DST. Actually, if seed is smaller than root low, root equals root left. If seed else, if seed greater or equal root high, root equals root high, else this thing. Oh, left, no, not root high, but root next. No member named. What? Oh, left, right. Not previous. Left, right. And then return seed. Okay, what is this monstrosity gonna do? I need to store the seeds equals malloc size. Well, actually, let's just do, I don't know, 496. That's our unchecked gonna work. Seeds n seeds plus plus equals n. Yeah, I hope we're gonna fit. We'll see there if if we don't. Okay, then for int I equals 0, I is not the number of seeds, plus plus I. And U32 s equals map seed I to fertilizers. Seed up, seeds I s. Okay, Does this map even remotely correctly? How much memory do I have? 2 kilobytes. I'm actually almost almost out of memory for this document. No, they all go to themselves. Okay, so that's not correct. Am I incorrectly reading the... this map? What do I have here? I have nothing. Okay, so read notes. Oh, do I skip this correctly? Oh. I don't. Why don't I skip that correctly? What do I have here? Oh, seed to soil map. What? Seed to soil map. What's going on? Okay. Oh, the examples have different mapping. Yeah, now I see. Okay. Oh, no. Soil to fertilizer. I've been... No, I've been dreaming here. Seed to soil map, of course. Okay. So, now what does this do? 79 maps to itself. 14, everything maps to itself. So this is still... So I do get 2 maps now, but... And wait, I still get 0. Oh, of course. So this Z variable, of course, was 0, because I don't have any tokens down for something. But why am I... Why am I not mapping correctly? Read notes. Insert n to the root. So let's see. Printf test seed root low root high root. I'm not testing anything. Okay, so that's not... Do I even have here? Okay, so root is null. So third is null here. Read nodes. Wait, what? Root. Oh, actually, no. Pointers are 16-bit in this system. Root is null. Oh my god. Can you be so blind? Okay. 79 maps to 81. 14 goes to 14. 55 goes to 57. 13 goes to 13. Okay. Let me see. 79 goes to 81. 14 goes to 14. 55 goes to 57. 13 goes to 13. So this map was source, so low, high, and destination. Let's double check what the example said over there. Oh. Seed number 79 goes to 81. Yeah, that's correct. 14 to 14, 55 to 57, 13. Okay, so that one is correct. Perfect. I don't need some of this stuff anymore. So now we copy this thing a couple of times. Let's save this. Seed to soil, then we get soil to fertilizer. Soil to fertilizer map. So, well, this is soil, this is fertilizer, and then I get fertilizer to water map. It's water, and then there is water to. Actually, no change of plans. What I'm gonna do is have a char dummy 80. I can do this instead, right? Just read the dummy line. I don't have to type out what the actual things read on that line. So we get seed to soil, soil to fertilizer, fertilizer to water, water to light. And actually we can do just node star maps, 7 of them. For int I equals 0, I smaller than 7. Plus plus I. Oh, now I ran out of memory. Out of memory, 34 bytes. 305 bytes. Okay, so so now the issue is that I don't have enough memory in my editor to have this whole document because my editor is so fat. I'm back. How's it going? How are you feeling about this part? So yeah, I think I'll get the first part done. Not too worried about this, but I mean I'm pretty sure the second part is gonna be inverting this map. Because that's exactly the kind of puzzle thing to do. I'll see. I'll see when I come to it. Okay, undeclared I. Let's do max 8. Oh, what is that emoji? My screen is so small to see. Some kind of green face. Okay. Oh no! Drive crashed. Okay. Now I crashed completely. Shit, I hope I didn't lose my file. I hope I didn't lose my file. Oh, just a second. Oh! Okay. Let's see how this goes. File not found error. What is going on? Oh, of course. No. Silly me. I have 2 discs. The whole. Now I'm swapping disks. C++ 64. Disk swapping experience. Okay, and then go to here. .23.5a.cpp. Please don't have corrupted, please. Okay, what is going on here? What did it save? Okay, so I'm here. Yeah, so this one can go away. I equals 3. So this one can also go away. This. Maybe I'll do 1 extra, I don't know. Well, actually, no. What am I doing now? I don't need 1 extra. Okay. So, undeclared third. Okay, so that looks good. Okay, so let's try to save now. I have no clue. Like, this is the second time what happened that the disk drive light stays on. And then it just hangs. I wonder where that bug is. Well, anyways, int m equals 0, m is smaller than maps plus n. No. So S equal seeds I. What did I do? What just happened? Oh, I did a page up, I guess. That was jarring. M is smaller than 7. Okay, yeah. S equals map S through maps I. No, maps M. And U32 S0 equals. No, I don't need this. This works just fine. So I'll do that. Actually, I don't need this one. So that looks good. Okay. Save. Please don't bug out on me. Okay, so what's gonna happen? So 35 is the smallest map. Yeah, 35. 13 maps to 35, and that's the smallest map. Okay, let me double check. Yeah, 35 location number. So yeah, seed 13 maps to 35. That's the one. Okay. So I think that code is correct. So let's now go daringly into the actual input and huge numbers and see how impossible this is gonna be. Oh, there's only 20 seeds. Okay. I should have probably added some kind of, yeah, always should have some kind of debug info, because now I don't know I don't know how long this is gonna take. What? That didn't take long at all. Okay. But what is the smallest? I need to print out the smallest. smallest equals -1. If s is smaller than smallest, actually smallest equals min smallest and s. Printf smallest okay. Save. Yeah, let me add in here. Printf generated map isn't b I. Okay. So this gives me a little bit of progress info. Yeah, it's the map gen. Okay, so it's it's the disk IO that is killing me. I feel so inclined to cheat a little bit and move all the disk IO into the RAM expansion unit and then benchmark only like how long it actually takes the CPU time to compute. Okay, so smallest is 5517 61867 5517 61867. Commodore A. And then let's go and submit. Um, 5517 61867. Actually, hold on, give me a second just before I type enter. I made a screenshot of this because I wanted to show how this submitting works. Okay, so 5517. Yep, it works. First try. Nice. Okay. That was fun. Always such a nice feeling to get it on the first try. Yeah. Cool. Cool. Okay, so what is the second part? Damn, that was so damn fast. Cool. And yeah, I'm just surprised that the C64 computed it so fast. Like, that's the that's the interesting part. So the thing is, if Eric Wassel wanted to be a little bit annoying, he would have generated the problem input in a sorted order, because then this binary map for me would have degenerated into a linear scan, and I think that would have been slow. But anyway, let's see what's in store for part 2. Actually, yeah, I'll go through the description. I have one work call that I have to take in about half an hour, so I don't think I have time to do this in half an hour. So what I'm gonna do is I'm gonna read through this, and then I'm gonna break off for to have that call. Then I'm gonna have dinner, and then I'm gonna come back to look into this. So let's see how this goes. Everyone will starve if you only plant such a small number of seed. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. Okay, so we're not inverting the map. We're pushing ranges through it. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, the second value is the length of the... Okay, start length. So in the first line of the example above, 79, 14, 55, 13. This line describes two ranges of seed numbers to be planted in the garden. Okay, yeah. Contains 15, yeah. Now rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. Yeah. In the above example, the lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer 84, water 84, light 77 temperature. Lowest location number is 46. Consider all of the initial seed numbers listed in ranges in the first. What is the lowest location number? Okay, so we're still finding the lowest. Okay. Okay, so these are ranges now. Actually, what are these numbers here? So these must be... So the length numbers are also huge. Okay. So we need to get ranges of numbers through here. I've been trying to brute Monte Carlo it, but the correct seed value for the answer is probably too narrow to hit randomly. No, I think... And I'm gonna stop watching now. Cannot get spoiled. A few other ideas I would like to try before I give up. Yeah, I think I have an idea how to go about this. Well, I do have 30 minutes. Let me give it a try. Yeah, you might get spoiled now if you continue. So give it a go. I'll catch you then later on. I might double this a little bit, and then if I don't get through, yeah, then I'll continue afterwards, after I have dinner and so forth. All right, I'm out. Yeah, see you, Arman Lex. Nice for you to stop by. Take care. Okay, so what I'm thinking is that I need a stack. So when I'm mapping this seed range to the next stage, no, I don't need a stack. I want struct seeds, seed range SR. Seed range has a low and a high. Again, it's low, high. And then, or actually, before I do this, let me save this to a B part file. So I still have the first part file. So now what I want to do is I want to map an individual seed range. Or actually an array of seed ranges. But that will split up the seed ranges. So in fact, when I process one node, it can be split into 3 at worst. So yeah, that's right. So I have a seed range. I map it through one of these nodes. So it'll be split into 3. And one of those is like an output, and 2 of those are intermediaries. That I still need to process. So I do need. So I need a vector, but unfortunately, like there's no standard library here. I don't have a vector implementation. So I'm gonna do my own vec. What did I do? Void push. Let's do. How tiny can I make this vector? How tiny can I make this? Just want to have a really, really tiny vector. t times capacity. X. So when I have this vector, that means that what I can do is I can map a whole lot of Oh, now I ran out of memory again. No, I crashed. Beep. Yeah, I got a crash. Oh no, my vector implement. I don't think I managed to save that. Oh. And now I'm swapping disks again. No. Why isn't it finding it? Actually, now I realize that this whole binary map walking that I'm doing is that now wasted work? Okay, I lost my lost my vector. Oof, hey Gopta, how's it going? Yeah, I lost my vector implementation now. Productivity issues. Let me see something like this. Okay, so this where this joint, I don't have this one that I would need. Yeah, let me compact this a little bit. So this should work. What's the thing with having to implement stitch stuff yourself? Because you can keep crashing like before? The compiler implementation that I'm using, LV Moss, it doesn't have an implementation of a standard C++ library available. So that's why I would be looking to do my own own vector if for this purpose. Okay, so well, let me see before I do that vector implementation. Actually, let me write the code that uses that vector, because that's gonna tell me if it's gonna work. So here's the code for mapping a single seed. But how would I map if I had a vector of seeds? Vector seed range PST. No, with star. So I would do while actually no. Let's do this case first. One seed range. So what I would do is I would look like at if source high is smaller than equal food nodes low. Oh, but these different ranges are gonna walk down the different paths of this map. So that means actually that now I'm starting to think I should probably not even have a map, because if I have a map, well, okay, let's see. So I would have a vector of seed ranges that are going down this node. Right? And I'm mapping the seed range. So all of these seeds are on the left. So this means that I would be pushing these down the left child, and else if source low is greater than equal root high. Then I would be pushing right. Otherwise, if they're all contained, if source low is greater than equal root low and source high is smaller than equal root high. Then they are all mapped. They're all mapped. So I would be pushing here. Oh no, now it again crashed. Now it again crashed. Darn. Darn. Crashing on saving, that's pretty bad. That is not helping at all. Okay, now it's almost half past. I do have to, so I didn't have time to do this B part, but I'll have to come back to this in a little while. But actually, before that happens, let's take a look. Just at the very end, let's take a look at the puzzle input. So if I have here in this map, I have about, so this is 25. About 30, and then this is less than 30, 25, 30. Oh wait, was that like, so that's about 50, and then this one has about 35. This one has about the same. So they're all about 25 to 50 items. So there's also about 50 items. So if I do a naive flat array mapping, there were like 1, 2, there were like 20 of these seeds. So that's 10 ranges. That is quite interesting. Okay, but in any case, I do have to break for now and for a bit. But I will be back after a work call and then a dinner. So I will catch you later, internet. Take care. Bye. Hello. Hello, internet. All right, I am back at it. So, oh, why is that flickering like that? Come on, what are you doing? What are you doing? Configure video. Power line frequency anti-flicker is set to 50 Hz for POW, but still that one is flickering like that. Okay, now it's settled. Cool. Yeah, so this is part 2. Earlier today I solved first part of this problem, and I started to solve a little bit on the second part, but to my disappointment I got a lot of crashes. I think this Commodore crashed on me a total of 3 times. Twice when attempting to write a file on disk, and then once the editor just crashed at some point. So that's a big productivity bummer. Now, what I'm thinking is that to help me a little bit, to debug why this write is crashing. So twice, or I think overall total 3 times now, when I've tried to save my CPP file on disk, I have gotten a crash where this disk drive just hangs. And I don't know if it's this disk drive or if it's my code. So what I think I'm gonna do is that I'm gonna use this Turbo Chameleon cartridge to emulate a disk drive. Let's see. Actually, in order for that to work, let me write settings. I have to turn this off. I have to put in a SD card here. So let's put that in. If it works, yeah. So now I think when I run this file browser, yeah. Okay, so here are all my files on SD card that I have had. And somehow I think I should be able to create writable drive settings, emulate 9, update mounted images, ask never always. I don't know what this is, maybe always? And write protect needs to be off. Write settings. But how do I then mount? So there was some kind of mount mechanism. Commodore H for help. Mount disk images is Commodore M. Mount disk image, but does it mounts the one that I have selected? Yeah. How do I create a new disk image? Well, I can use this one actually. This is something that I have created. Okay, so let's see what happens if I now look at what's on my drive 9. Okay, perfect. So what I want to do is move my C++ code from the real floppy into this SD card. Oh. That was the wrong one. C++ 64. No? Still crashing? So, am I now mounted? Do I again need to do reset with cartridge? Present C++ 64. It's not loading anything when I do this. What is going on? Why cannot I load from drive 8 when I emulate device 9? File browser, mount. Load C++ 64 from 8. No, it doesn't do anything. That is weird. Okay, so there's something not quite... Or do I need to do emulate the device drive 2 with 9? Is this what I need to do? If my physical disk drive is drive 1. I'm not sure if that's how it's supposed to work, but let's give this a try. Reset with cartridge. No, that didn't help. Okay, well, I guess then I am not doing that. That is weird, I don't know. Does this work now? Yeah. Okay, so something, I think there's something is maybe buggy or that I don't understand how it works. Or maybe when I'm emulating disk drives, I cannot have physical drives at the same time. Okay, so I guess we're stuck with my my dangerous save function. Oh, wrong disk. I need to remember to flip disk. Okay. So the thing I was stuck at is that in the second part I have these ranges of seed, not just individual seeds. So I have ranges of seeds that I need to map through these things. And my idea was to use a vector, and I started implementing a vector until it crashed. So actually while I was having dinner, I copied an implementation of a vector that I've implemented before. So now I have a vector type. And then what I want to do is have a struct of a seed range low and high. And then have the seeds in here. I already had this here, okay. So that one can go away. So let me now try to save. Okay. So what we want to do is walk these seed ranges. So we want to first off we want to parse these seed ranges, and these are the starting seeds. Seeds push. Actually, I do seed range. Yes. S dot low. S dot high. So then push that seed. Okay. So now I have the initial seed ranges in a vector. Then what I want to do so I read all the nodes and then for all the seeds wait a second. Yeah, for all the seeds, initial seeds, I want to map them through the seeds through this map. And I figured that I want to take these over yeah, so this is, so I'm going to map all the seed ranges through this first mapping node. Actually, these initial seeds, they don't go into this. Oh, but they do. So actually what I want to do is maps 0 seeds equals seeds. Yeah, initially all the seeds are going to be part of this input for the first function. And then I am going to run for int m equals 0, m is smaller than 7 plus n. Let me save this. M0 m until 7. Map from m to m plus 1. Yeah, this this is how I get it. But now I'm accessing out of bounds. So actually what I want to do is 8 of these maps up. Maps 7 equals allocate a output for those. So my final answer is going to be in here. And that's the initial one, and then the smallest is for u16i equals 0, I until map 7 size plus 5. Map 7 I. Oh, that's ugly. Low. But yeah, that's how that would compute. And then like this. Oh no, now it crashed. Hold on, actually now I got an idea why this crashes. That's probably my bug. Okay. Yeah, now I got an idea of actually what to debug. I may have a bug with the multi-select feature. Maybe. Okay. And then okay. So actually now not use this multi-select feature, thinking that maybe I did a bug in that implementation. So maps 7 equals, hey, I solved it the noob web and now I know how to do it properly now. Okay. Well, don't spoil it yet for me. You can tell me the proper way after I get this done, if I get this done. We'll see. So map m to map m plus 1. Okay. And then U32 smallest equals -1 for I from not U16 I from 0 until maps 7 seeds size plus I. Smallest equals minimum of smallest and maps let me do actually back seed range final equals map 7 seed. Now I can do easy. Final size smallest is small, minimum smallest and final I. Okay. So now, yeah, not using the multi-select feature. I'm considering that to be tainted. Okay, and then save. So map 0 seeds are the initial seeds. Map 7 allocate, that's the output. From int, we map all those through. Smallest -1. Finish is fin I dot low. How much did your Commodore setup cost? So this Commodore 64 is the one that I had from back when I was a kid. And then the tape drive also. But then I purchased these disk drives, Turbo Chameleon, RRNet, and then the 1084S. Overall, like I purchased all this peripheral stuff. Overall, I must have spent more than €1,000. I'm pretty sure. But this is like over several years. So of course that's like, you know, hobbies cost, right, kind of thing. Wow, how much would a Commodore cost now? I think the rule of thumb kind of like is that the Commodore unit itself, like a little bit more than €100 maybe, like that one that is functional. Disk drives are maybe 100 as well, depending on the condition. Yeah, this Turbo Chameleon cost a bit more than €200. It's an FPGA implementation too, so that's quite expensive. I'm still a little bit of the edge if that was worth it. I mean, it's got a lot of features, but then again, it's a little bit quirky, and the development seems to have been abandoned by now. So the project has kind of like come to an end. It feels like, but still, I mean, don't get me wrong, it is working pretty well for this setup. So it was a decent purchase for that price. Much less than I expected, as it's over 40 years old. I mean, do remember that Commodore was the most manufactured computer unit. So there's a lot of Commodores on eBay that you can still buy. Like they are not rare by any stretch of the imagination. A lot of Commodores. Okay, let's see if I can do this mapping. So now I'm imagining that my map function is from node node source to node destination. And within that, okay, so here's the deal. I have a source node that has some seeds in it that have a seed range. So I need to loop for u16i equals 0, I smaller than source, seed size plus I. So I get a seed range, source, seeds, I. Okay. And then I need to figure out so I'm mapping it through this function. So first off, if seed range low is smaller than source low, which means that in the seed range that I'm processing, some of them are smaller than the current mapping range. Those need to go to the left. So I'm gonna do source left. Oh, actually, if source has a left child, source left push seed range low. Actually, can I construct like this? Seed range low, source low. Does this compile? Oh, something is wrong. I am not even getting my compilation error messages. Okay, I think I need to reload this file. Okay, so close. be open. That's another bug that keeps coming up. So somehow the PC side gets stuck and it doesn't recompile. Oh, and I oomed. How is that possible? How is that possible? Crap. Okay, my productivity is kind of down the drain today, it looks like. That's kind of curious. That is kind of curious, okay, but yeah. Open 2023.5e.cpp. No member named push in node. Okay, so this map function actually can go. I don't need this one anymore. Oh, left seeds dot push. Present LU. Okay, save. Else this range goes to the destination. Let me do node. Actually, node D equals source L, then source L. Otherwise, it's gonna be destination. So that's how it's gonna work. Do I need to cast? I don't even need a cast. Okay, that works. Okay, so then if source high is greater than or seeds, so we have seeds that are above that range. Then equals source right, and we use that one. Otherwise, they fall through. Push. Seeds high source. No. Source high is high. Okay. And then for any seeds in the range of this current node, if actually, can I? Ooh, actually, no. This needs to be minimum of seeds high, source low. And this needs to be seed high. This needs to be maximum of source low. Seed low, source high. Yeah. And then there's the question of the seeds that actually fall within this node mapping. So let's do it like this. Equals max. Actually, can I do this? Okay, so S low equals source low. And here S high equals source high. And now this check means that if S low smaller than S high, DST seeds push S low, S high, or actually S plus equals, what was the node? Low high DST. Low high DST, low. Actually, let's put this. Where do I add this DST thing? I do it in read nodes. What is my read nodes? Here. DST is equal DST minus source. Yeah, so this way I can do here just a plus. S low plus equals DST. DST. Okay, that's a little bit silly naming, but whatever. DST. And they go forward. And when I've done that, I need to do if source left map source left DST. If source right map source right DST. But before I do that, actually, source seeds free. I want to free up that memory from that previous node because that one is now processed. Okay, well, that was some programming. Let's see what it prints. It prints smallest equal 36. Okay, where's my pen? How can I have forgotten or lost my pen already? Not there. Oh. I have a traveling pen. Smallest equals to 36. Well, I'm not sure if that can be right. Let's see what the example said. $46. So that's not correct. Okay, so let's get an example from here. Lowest location number can be obtained from seed number 82, which corresponds to soil 84, fertilizer 84, water 84, light 77, temperature 45, humidity 46, and location 46. Okay. Okay, so let me do some debugging here. Yeah. So these ones go to the left. This is back. Oh, this. There, these ones go to the right. Oh no, and then no. Oh my god. Oh, the stability. Why am I doing this? Okay. Disaster struck. Okay, so there I actually ran out of memory. Oh, interesting. Okay, so many bugs. So many bugs. And now it's zooming. Okay. Okay, now I am really getting into the brittle parts. Okay. Let me compact some of this stuff. So why? So what do I need to do to be able to debug this? I need to be able to know where these things map. And what's the most efficient way to do that? Let me read this through once. So I have my source mapping for the seeds that are going through this source mapping. If they have seeds that are on the left side of this mapping range, they will either pass through or go to the left child. Whichever they're going, push it their source low minimum of seed high source low. Yes. Source low. So I clip this now to this part. And if I have nodes that are higher, node D. Actually, did I? Yes, I do. What did this print on the... $79 93 is 55, 68. 29 goes to 89, 93. Yeah, 55. Okay, so those starting seed range numbers, those are right. Those are right. Maybe I will debug it here. 4 U16 I equals 0. I smaller than maps m plus 1. Seed size plus printf oh no, what did I do? Oh, I tapped Command A. Okay. No biggie. No biggie, we can go back. I wanted to type Command S. Maps m plus 1 feed I low m plus 1 feed I high. Cool. So what does this do? Ooh, prints a lot of garbage. Okay, so there's something wrong for us to debug. So printf stage %d. Stage 0. This is what they map to. Stage 1 is what they map to. Oh, but now we really would need to correlate that with the example text. But yeah, that's garbage. Okay. How do I get -1 in there? How do I get -1 in there? So that I believe the bug must be in this map. Or actually, before I do read node map where am I? Here where am I creating these nodes? Oh, and this is wrong. Source DST. Smallest 46. Was that the right answer for the example? I think that was. I think that was the right answer. Let's see. So 46. Yeah, 46. Okay, so I got it right. Okay, so yeah, I don't have high confidence with this stuff, but I'm going with it. Oh, you can do it. Ooh, I got a number. I got a number. I have zero confidence in this. 574 51709. 574 51709. Oh, when the editor is so brittle, I'm crashing left and right in the ear that it's hard to place faith in this thing. Answer 57451 Oh, jackpot! Oh my god! Hey, that's just really well done. Thank you. Oh my god! Like I think there's like 5 crash bugs, critical crash bugs in this thing that I really should fix up. Yeah, it's really really tough when the editor is like I knew. Oh, it's Arnold Valenci from Reddit. Hey Arnold, nice for you to pop by. Great to have you. What approach did you take? Yeah, actually, I think while I was solving it, I was mumbling through most of that stuff. So let me try to like quickly draw my solution. How would this work? Maybe if I put this in. Maybe if I put this in here, does this cable manage? Come on, you can do it. If I have enough cable from here. Side. Okay, maybe that works. So, so the way I thought about it is that when I have these seed, you know, not individual seeds, but these seed ranges to go through. that and basically I wanna, you know, calculate them through this mapping of these like piecewise linear mappings of things. So what of course happens is that, you know, when you go through those rules, like you'll have like a subset here that will map, you know, to some other range, and another subset here that's gonna map to another range. So I created from this mapping, I created this binary tree of ranges of like mapping ranges, and then a left and a right child for those, and then a mapping range in there, and then a left and a right, and so forth. So those functions can be represented as this kind of like walking down a binary tree. So if we have just individual seed, you can go like if this left and right is like like you have the low and high ranges for each of these low and high, and when I create this binary tree in a binary search tree order, this means that this low value is bigger than the high value here. So the things to the left are to the left of low, and the things to the right here are to the right of high. So if I have one seed number, if I enter here, I can look at like, does it fall in between this range? And if it does, then I map using this mapping function presented by this rule. And then it's if it falls inside this range, it's gonna go onwards to the next stage. So if this first stage was, for example, the seed, what was it called? Seed to soil. So then it will go to the next soil to fertilizer stage or whatever. But if the seed number doesn't fall into this range, I can look at if it's to the left or to the right, and then walk this binary tree to the left or right accordingly. And then in the end, I always find like it's either gonna find the mapping and then it's finished, or it's gonna fall through, it's gonna find the very last mapping rule here and not do a match. And if that happens, then I know that that's one of those pass-through values. So that's for the first part. But then the second part idea is that I need to run this whole thing for these ranges of seeds at one time. So when my range of seeds walks through this binary search tree at any stage, I have to look at how this range of numbers matches against this range here. And you get these different ideas, like so actually visually I was thinking of this like as if, because we're talking about seeds here, that this is like a bowl of seeds that is organized like this kind of like binary fashion, like this. And you know you're putting your seeds down from the top down. And so some of your seeds in the range are gonna fall to the left because they are outside the low range here. Some of them are gonna go to the right side because they are outside to the right of this range. And some of them are gonna fit. So you have these three scenarios. Basically, this range that you have, part of them go to the left, part of them go to the right, and part of them fit in this mapping range. And whenever they fit into this mapping range, they go on to the next stage. So that's the idea. And then what ends up happening, which is what I was kind of worried about in this code. Oh, let's actually admire the 2 stars. Return to Advent calendar. Yay! It's 2 stars on the 5th problem. So what I was kind of worried when I was writing this... Oh, can I get back? No, I cannot, okay. it crashed. That when I'm splitting up these things from left to right, it basically means that you have one seed range that potentially splits up into 3 new ranges. So that's like multiplicative, one range becomes 3 kind of deal. And the challenge there is that if you have this kind of multiplicative thing, that means that you're going to be in the exponential land. So actually I was kind of worried when I was executing this, there would be no way for the C64 to get through it. Oh. HDMI didn't sync. Okay, now it syncs properly. So I'm curious to actually run this again and time it, how long it takes for the C64 to run. Because it didn't actually take that long at all. Let's give it a run. .5b.cpp. So yeah, so here this node structure is this like node of this binary tree. So there's a low range and a high range. And then the delta. I think this is probably better named the delta. Oh, actually, let me not do that now. And then the left and right children. And then at each stage of this surge, we have the seed ranges that live at the current stage. So here you can see this mapping. So this map function maps an input seed range or an input node. So all seed ranges that are currently like left at a specific range, they map it through to the next level. My solution was to start from location and map back to seed and check if my seed exists in the given seeds. So check location 0, then 1, and so on. It takes 15 seconds on a modern computer, so I'm not sure if it would have worked on. Also, did you start from like the finished number and you mapped backwards at each stage? So you started at like best answer would have been 0. So you see what would have produced 0. So you basically map back at everybody. Yes. Okay. Yeah. Yeah. That's a nice approach, I think. It will run through the right code. But yeah, you will then be running like these individual seeds at a time. So, and I think that's why they put it like these massive uint32 numbers. It's gonna be churning through these quite a lot. But yeah, so let's do this. So here I'm curious to take this one. So what I'm gonna do is I'm gonna time this code. So let's do tick t0 equals tick. Oh, unknown type name tick. Actually, let me move this here like this. So I do have this timing function. Tick.h. Undefined symbol tick. Wait, what? Is my timing function not in? Undefined symbol tick. Let me see what's up with that. So T1 equals T2. Or actually, no, not here. Not here, not here. I do need to find the smallest. Here. Tick T1 equals tick. Okay, let me save this. How much bytes can have an integer in your setup? So if I have an int, just a regular int, that is 16 bits. So that's from 0 to 65535. But of course, Commodore 64 is an 8-bit machine. So natively, the CPU works just on like U8 or like uint 8T types. So that's from 0 to 255. But because this is compiling against the LLVM-MOS compiler, it can emulate. Like I can do uint 64T, and it will emulate it in using 8-bit arithmetic, and it'll do 64-bit integers. And I can actually, like, if you wanted, you could do uint 128 as well, and other arbitrary types. But actually, let me double check. Hold on, I'm gonna look into this header code. What's up with this function? Oh, okay, now I understand. Okay. So I need to save this. So my server had... Oh, and I did get a crash. Crap. Yeah, I need to figure out this crash. This is pretty bad. This is pretty bad. So this is happening quite often now. Is that my bug? Now I don't think I used this multi-select feature now, so maybe it's not that one after all. So yeah, I really want to know how long it takes on take care of the... Yeah. Oh yeah, very, very nice for you to pop by, and yeah, I'll see you at the subreddit community. Yeah, take care and catch you later. Yeah, see you soon. Bye. 8.23.5. Okay, so now this compiles. So now I can do T1 minus equals T0, and then T1 print. Yeah, okay. So now I'm measuring only the computation. Basically, the time that it takes to build the binary tree, that is the file. This is disk I/O. Actually, yeah. Let's measure this one. Tick TA equals tick. and T0 minus TA. T0 and equals TA. Disk IO 3 build. T0 dot free walk or seed mapping. Okay. So how long does it take? Oh, this is running on the example. 2 seconds. Disk IO seed mapping 0.1. Well, no wonder the example was quick. The input. No, it runs out of memory on my... Okay, so let me do this. 178 bytes print is running out of memory. I need to figure something out on that one. That's really annoying. So disk IO 20.5 seconds and 5.6 seconds. So I solved this problem in 25.6. No, 26.1 seconds total. Yay! Disk read was 20.5 seconds. And the seed mapping 5.6 seconds. Okay. So I could essentially say... Well, maybe I won't say that. Yeah, that feels pretty good. How do I simplify this code? Okay, maybe I'm going to take a moment. I want to make this code like green a little bit cleaner and try to make it like, you know, read smaller and so forth. So yeah. Oh, these ones can go away. And this one as well. Okay. So 106 lines of code. That includes this printing and timing. Can I write T1 minus T0 dot print? I can. And then, oh no, I meant to write T0 dot T8 in T1 minus T0. Okay, perfect. Okay, cool. All right, so that is everything for today. I'm clocking off. I'm gonna read and write up in the blog and visit and read the community stuff for a while. Perfect. So take care, anybody who stopped by to watch, and I'll catch you guys later tomorrow. Bye.